Hello everyone, so today I'm going to be doing another video. This time is on Newton's laws of motion, or in the topic of Newton's laws of motion is about using the formula force equals mass times acceleration when F is the resultant force, okay? So to start off with, first I'm going to tell you what resultant force is. So the resultant force is the net force, is the sum of all the forces acting on an object when you take the direction into account, okay? And it's very important that you take the direction into account because forces are vectors. So that means that they may have the same number, but they have a direction. So I can have two forces. So for example, here in this example, I can have force 1, which is the pull of the tractor, and force 2, the force on the car due to the mud. And they can have the same number. And if I would add the forces together without taking in consideration the direction, I would end up having twice as much the force, right? However, because I take the direction in consideration, I know that the resultant force is F1 minus F2. So I decided that minus is going to the right. And that if F1 and if F2 are the same, then it means that I have no acceleration. And this is because the resultant force equals mass times acceleration. If my resultant force is 0, because the two forces are the same, or in other words, they cancel each other out, then it means that 0 equals mass times acceleration. This means that acceleration is 0. So basically, resultant force, again, is going to be the force, when you add the forces, all the forces acting on an object, and you take the consideration, or you take into consideration, sorry, the direction. And that's going to tell you, as you could just see, not just an information about the net force on the object, but if it is accelerating or not. So let's see this example here. Imagine that I want to use Newton's second law of motion, and I have two masses, and I have the engine thrust and the tensions in the tow bar that is acting both on the car and on the smaller trolley. I'm going to call it a trolley, okay? So all that I need to do is first I think about the car. What are the forces acting on the car? And I'm not putting here the gravity and the reaction because I'm only thinking about the motion of the car forward, okay? So I have F, the engine thrust, and then I decide again to think that tension is going to be negative because it's going towards the right. So I put F minus T equals M, the mass of the car, the big M, times acceleration. For the trailer, I'm going to say that there is only one force acting on the trailer. I mean, you could think about friction, of course, but they are not putting friction, so I'm really just doing exactly as this exercise is, which is, by the way, from AQA, okay? So I would say that the tension on the trailer then is equal to the mass of the trailer times the acceleration, and the m is going to be the small m, okay? So if I want to know the resultant force in total, I add up the resultant force for the car and for the trailer. So I get big MA plus small ma, which is going to be the adding of the two masses times acceleration, okay? So this is, for example, of course I'm not using numbers here, but these are ways that you can think about these questions, okay? Let's look at another one. So this say, find a formula to calculate the rocket's thrust and state the condition needed for the rocket to take off. So again, it is showing the engine thrust, it is showing the weight of the rocket, and in this case, all that I need to think about is instead of the horizontal direction of the forces, which was like the last exercise, I'm now thinking about the vertical ones because the rocket is going vertically up, okay? So, resultant force, Fr, equals mass times acceleration. So, T, the engine thrust, minus mg equals mass times acceleration. I decided, as you can see, that going down is negative. So, therefore, I can say that T, the rocket's thrust, which is what they are asking me, equals to mg plus ma. So, the condition, so this is the answer. That is the formula to calculate the rocket's thrust. If I now want to know what is the condition that I need for the rocket to take off, then it means that tension needs to be bigger than mg for me to be able to have an acceleration bigger than 0. So again, I need then that tension is equal to, bigger than mg, the weight, for the rocket to take off. So I don't know if you realize, one of the exercises I had no acceleration if the forces would be the same in terms of sizes but opposite in directions. And in this exercise I'm thinking about acceleration. So that means that if I have a resultant force that is equal to 0, my object has no acceleration and is therefore moving at a constant speed. Either if that speed is 0, meaning is stationary, or if that speed is a certain number. If my resultant force is different to 0, then my object is going to accelerate. And acceleration can be both accelerate and decelerate. Acceleration is going to be the first one, so the acceleration, the positive one, if my velocity is increasing, and is going to be decelerating if my velocity is decreasing, okay? So, as you can see, again, resultant force can tell you not just information on the forces acting on the object, but also on the movement, okay? Let's think about this exercise. I have a guy on a lift, I have the tension from the cable of the lift, I have the total weight of the lift and the occupants, and I want the formula for the resultant force for the lift and state how the tension and the weight compare for the situations of lift moving at a constant velocity, lift moving up and accelerating, lift moving down, up and decelerating, lift moving down and accelerating, and lift moving down and decelerating. And think about when you need to do this, and it can look overwhelming. Just think about the separate forces first, see what you have, look if you want to think about the vertical or the horizontal direction only, and then just use the resultant force. Calculate the resultant force for the situation, and then just look what happens if you, or what you need to have, the conditions you need to have for acceleration to be 0, which is the constant velocity, the acceleration to be bigger than 0, which means accelerating, acceleration to be smaller than 0, which is decelerating, okay? And you will be able to do this. So that's what I'm doing. First of all, to do this exercise, I'm saying that the resultant force equals mass times acceleration. And I'm substituting resultant force by tension minus mg. Again, I'm considering going down to be negative. And I'm saying this is equal to mass times acceleration. So, if I want constant velocity, I want A to be equal to 0. Therefore, my tension and my mg, my weight, need to be the same. So that means that the forces are balanced. If I want the lift moving up and accelerating, then I want the acceleration to be bigger than 0. So that means that my tension needs to be bigger than the weight. So the force going up, because the lift is moving up and accelerating, the force going in that direction needs to be bigger, okay, than the force trying to pull it down. Lift moving up and decelerating. So if I'm decelerating, my acceleration is smaller than 0. So for my lift to be up and decelerating, I need to have that the tension is smaller than mg. So if my resultant force is opposing to my movement, I am going to decelerate, okay? Lift moving down and accelerating. Now, this is where it can get tricky. Because acceleration is downwards now, I want my acceleration to be smaller than 0. So I want my tension to be smaller than the mass times the gravity. And this is again because the lift is now moving down. So I want that the force that makes the lift go in that direction to be bigger. Okay, so I want the forces to be unbalanced because I want acceleration. And I want that the force is bigger in the direction of the movement because I want the lift to accelerate. Lastly, lift moving down and decelerating. Again, acceleration is going to be upwards now. So again, there is a trick because I am decelerating. So my acceleration needs to be opposing to the movement. That means that my tension, so my force opposing to the movement, needs to be bigger than mg, the force trying to pull my lift down, okay? So if you didn't quite understand this exercise, look again at the tip that I gave you in the last slide and do the resultant force first, the formula, and then just look at the situations. It could be that you're more mathematical and you want to look at the numbers or the symbols that represent numbers, or it could be that you're more visual and you just want to look at the vectors. Either way, as long as you have it right, that's fine, okay? All right, let's look at this exercise as well. So let's think about if the tension of the cable is less than the weight, okay? So what is going to happen? That's going to mean that the lift is going to move up and decelerating, so therefore my velocity is bigger than 0 because I'm going up, and decelerating, then my acceleration is negative, so it's smaller than 0. If my lift is moving down and accelerating, then my velocity is smaller than 0 because I am going towards the negative side, so I'm moving down. And then the acceleration is going to be smaller than 0 as well because I am accelerating, but I am accelerating downwards, okay? And now, what happens to the tension of the cable? So the tension of the cable will be greater than the weight if the lift is moving up and accelerating. So that means that I have both a velocity and an acceleration that are bigger than 0. And the tension in the cable will be greater than the weight if my lift is moving down and decelerating. So again, lift moving down, therefore velocity smaller than 0. Decelerating, therefore acceleration is in the opposite direction than the velocity, so therefore it needs to be different, so it needs to be bigger than 0, okay? So these are all exercises that you can do using force equals mass times acceleration. Let's look at another one. I have a pulley here. I have two masses, and I'm considering to be positive if you go in the direction of the big mass, okay? So first, you need to find the resultant force for the two objects. Start with one, do the other. And then, if you want the total resultant force, then add the resultant forces for the small and then for the big mass. So, resultant force for the big mass, I'm actually starting with the big mass, is going to be mg, the weight, which is going down, and I am saying that that's going to be positive, minus tension, because the tension, look here, is in the opposite direction. That's going to be equal to m, big M, times a, the acceleration. For the small one, now I want this to be positive, so if you're finding it difficult to decide which of these two forces is positive, instead of making this curve or half curve, just put them all straight, so put a line, a horizontal line, where you get all these forces, and think that this force, T, is at the same direction as the mg, and think that this other force, the other tension, is in the same direction as the other mg. So these two are positive because they are going in the same direction, and these two are negative, okay? So the resultant force for my smaller mass is going to be T, the tension, minus mg. And again, this is because going in this direction, clockwise, is going to be positive. If you have trouble visualizing this, imagine that the line on the pulley is completely horizontal and the direction of mg is the positive one, this big mg. So T minus mg equals ma, where the m's are going to be the small m's because it's my small mass. So the resultant force is adding the two resultant forces, so I get big mg minus T plus the other resultant force, big T minus mg, small m. So the tensions cancel each other out, and then I have mg, big M, minus mg, small m. So I get that the resultant force equals m minus m, big M minus small m, all multiplying g, and this is going to be equal to, according to Newton's second law, the two masses times the acceleration, because remember, this part is being done here, okay, but I still need to add this part, because force equals mass times acceleration. So far I just picked out all the forces, and this is the part that I say is equal to mass times acceleration, okay? I hope it makes sense. I think it makes sense, but you know, you never know. Finally, I think is the last one. Let me check. Oh, I didn't want to show everything yet, but I think it's the last one. Yeah, it is. So finally, imagine that now I have the situation where I'm sliding down a slope, okay? So again, now I have forces, but I have forces that are at a certain angle, so now I need to have trigonometry in. So first I'm going to find all the resultant force for the horizontal forces, then I'm going to find all the resultant force for the vertical forces, and then I'm going to see what happens. Okay, I can combine them together, or I can just leave them as such. I can leave them as such because they are different directions. So I'm saying horizontally, this is what I have. mg, this one, times sine of the angle theta, where this is theta, so theta is here, and that's the opposite angle, so that's why it's sine here, minus, what is the other force that I have horizontally? This one, friction. So minus F0 equals ma, so resultant force equals mass times acceleration. I decided that going opposing to the acceleration of the block is minus, so it's negative. Vertically, what do I have? I have the weight. Now again, remember that this is the angle theta, so this guy here, that is the same length as this vector in here, is going to be the cosine. So again, mg cosine of the angle equals ma, okay? And that's how I do it, okay? I can have them vertically and horizontally. They shouldn't be mixing each other, and then I can figure out the forces, okay? I have the resultant forces in the whole situation of the box sliding down a slope. Imagine that I have an engine force. So imagine that I'm not just sliding down the slope, but I'm also having a force that helps me to slide down a slope. So that force is going to go in the same direction as the acceleration. So I'm going to consider it to be positive. So I'll just put Fe for engine force plus mg sine of theta minus F0, the friction, equals ma, where F0 is the friction from the surface and the air resistance. Okay, so these are all exercises to do with using force, resultant force equals mass times acceleration. I hope it makes sense to you. If not, you can always contact me directly. Up to my next video, which maybe is tomorrow. Keep happy and healthy. Bye.